Hi everyone! So for our first video, I'm going to do a quick proof of the Pythagorean Theorem. We've all seen the Pythagorean Theorem. We were all introduced to it when we were kids, and it's just the basic idea that when you have a right triangle, the sum of the squares of the two legs equals the square of the hypotenuse. A squared plus b squared equals c squared. There are hundreds of proofs out there of the Pythagorean Theorem, and I think it's important that when we learn something in our class that we understand why it works. So I'm going to show you my favorite proof of the Pythagorean Theorem. I like it because it's pretty simple, it uses pretty basic algebra, and it's easy to follow. So here we go. Okay, so on this page we have two squares. If you look here, there is a big square and a smaller square inside it. And we have the small square put inside the bigger square so that we end up with four of the same triangle, four congruent triangles. These triangles, because a square has four right angles, the triangles are right triangles. And I've gone ahead and labeled our sides of the triangles as A, B, and C. We'll also notice that the smaller square ends up having C as the length of one side, and the larger square ends up having two segments for each side, an A and a B. So if we add them up, we get A plus B as the length of one side of the larger square. Now, in order to do this proof, we need to know a few things about triangles and about squares. The area of a triangle is 1/2 base times height, and the area of a square is one side squared. So knowing that, we look at what we have here. We have A plus B is the side of the large square, so the large square's area is going to be A plus B squared. If we look at our four triangles, 1/2 base times height, since they're right triangles, we have base times height is B base times A, which ends up being the height of this triangle. So we end up with 1/2 AB as the area of one of the triangles. But since we have four of them, we multiply it by 4. And then the small square has a side of C, so its area is C squared. Now, looking at that, in order to do this proof, we're just going to do a little bit of subtraction. And we're going to say that if we want to get to the area of the smaller square, we're going to take the area of the larger square and we're going to subtract those triangles, right? If we take this big square, we get rid of these triangles, we're going to be left with just the small square. So let's go ahead and do that. And we end up with A plus B squared, that's the big square, minus the 4 triangles is going to equal the small square. Now we just do a little bit of algebra. If we take this A plus B squared, we're going to work on it over here on the side. We have A plus B times A plus B. If we use our distributive property in algebra, we take A, distribute it, and we take B and distribute it, we end up with A squared plus AB, and then we look at the B, we take BA plus B squared. But in algebra, AB is the same as BA, so we can combine those together in the middle and say that we have A squared plus 2AB, ignore this right here, plus B squared is what we end up with for the A plus B squared. So I'm going to put that over here. I'm going to say A squared plus 2AB plus B squared. Now let's look at this 4 of the 1/2 AB, right? If we take 4 and we multiply it by 1/2, we end up with 2, right? We get 4. Let's look at it over here on the side. We have 4 over 1 times 1 over 2 equals 4 over 2 equals 2. So then the AB just get carried down, and we end up with minus 2AB. And then on this side, we can just bring down the c squared. So what do we have? Let's clean it up. Let's notice that we have here 2AB, and here we have minus 2AB. So when you have a positive and a negative of the same thing, they're going to cancel each other out. So we know that the 2AB and the negative 2AB go away. We end up with a squared plus b squared equals c squared. And if you'll remember, that's the Pythagorean theorem. That's what we were trying to prove. So when we end a proof in math, we like to end it with QED, which is short for a Latin phrase that basically means that which was to be shown. And we have shown what we wanted to do. We have proven the Pythagorean theorem. And now the next time you are given a triangle and told to solve for the third side, if it's a right triangle, now you know why it works.